Hello, everyone. Thank you for joining us again from whichever part of the globe you're in. Thank you for tuning in at yet another episode here at amazic.com, where we talk to influencers, experts, and leaders in the Kubernetes and the cloud native space. That's our exclusive focus. And we want to talk about all things Kubernetes, all things cloud native. And KubeCon is happening just around the corner. And so it's very timely as well that we're talking about this week. We're going to be talking specifically about Kubernetes security, and we talk about a lot of these kind of topics. So if you want to hear more like this, head over to amazic.com. We've got a lot of interviews, articles, job listings, event coverage, and a whole lot of stuff happening there. I'm Twain Taylor, editor at Amazic. And I'm joined today by Seth Goldhammer, who is the VP marketing at a startup named Spyderbat. And they are innovating in the space of runtime security. And that's our main focus for today, runtime security. So if security has been on your mind, you're going to want to listen in closely as Seth shares some of the key ideas that that Spyderbat, the key things that Spyderbat is working on. So Seth, it's great to have you. Thanks for joining us today.
Oh yeah, thank you, Twain. Really appreciate you having me on.
If you could get started, Seth, with just telling us a bit about yourself and your background up to Spyderbat, that would be a great start.
Yeah, absolutely. I've been in cybersecurity for a long time. I actually had started a network access control company back in 2001 called Roving Planet, where I served in product management, product marketing roles. And that was bought by Tipping Point, which was a subsidiary of 3Com, and served as a product line director focused on security products for both Tipping Point and then the parent company 3Com. Then HP came in and bought that whole enchilada in 2010. I didn't last long after the HP acquisition, and was very fortunate to find right in my backyard was a company called Logarithm, which there are about 100 people, and Chris Peterson, the co-founder, CTO of Logarithm, was wearing many, many hats still. He was running product management, he was head of engineering, he was running IT, doing everything. And so I came in as the first product manager to work with Chris. And 8 years I was at Logarithm, and at building product management and product marketing and solution marketing teams at Logarithm as we became a leader in the SIM space, and really had an amazing time, and appreciate all the relationships and amazing people that I got to work with there at Logarithm. Spyderbat is actually the founders of Tipping Point. So this is going back to, so Mark Willoughby-Clemere, Brian Smith, after they started Tipping Point, which was really created the intrusion prevention space, network intrusion prevention. When they left 3Com, they started a company called Click Security. And Click Security, you can almost think of it as a predecessor to what we call XDR now. They're really trying to match that network telemetry and endpoint telemetry to understand, if I saw an attack on the wire, did it land? What happened to that attack? And the Click Security was acquired by a company called Alert Logic. They're a large managed detection response company. And there they learned a lot about the security operations, the analyst and operations workflow. And really what led to them starting Spyderbat was seeing, how we investigate security concerns as we looked at cloud native environments, as we saw really that the cloud and digital transformation as organizations that were taking place, that the ability to really understand what's happening in these environments, the ability to be able to recognize something that needs your attention and have the information available to know what has happened. How did it get to this point? What's its impact? What its scope? Just the existing tools really just fell short. And that was the impetus behind creating Spyderbat, and why we're so focused on
we're going to get to that in just a sec.
Space.
But yeah, we're going to get to all of those details. But
yes. So that's, sorry, my background bled into Spyderbat background. Sorry.
Yeah, I was going to come to that actually. But it sounds interesting. Sounds like you've got a really deep, background in monitoring and security,
That's
and
right.
looks like you've watched or been part of multiple acquisitions over the years. So yeah, that's pretty good. I think I think we'll be hearing from someone with ground to the years over the years, and so that's great. I'm looking forward to our conversation. Um, so Spyderbat. So without getting into all of the technical details, if you just give us briefly, how long has it been that Spyderbat has started?
Yeah,
Just
we're fairly new. We've been in the market. So the company started a couple of years ago. We've been in the market for about a year.
Mm,
Having said that, certainly as I just talked about with the background behind Spyderbat, there's a lot of many years of experience that
mm,
has gone into Spyderbat beyond the years of the company.
all right, neat. So security. When I think of it, I think that we've had kind of like a watershed moment in the past few, let's say, 2 years or so, where security has really come to into the spotlight, especially with all of the hacks we've had, the SolarWinds and Log4j and all the others. Huge hacks, that have affected just thousands of organizations.
Mhm.
So so with all of these things happening, what impact has it had on security operations itself? How has that changed? And you, someone who's been connected, watching the space over the years, how have you seen these incidents itself? What kind of impact has it had on security?
Yeah, I think that it's had a significant impact. Many people lost their Christmas last year due to Log4j, and and you brought up SolarWinds. That was such an amazing kind of reveal, I guess, to the compromises that can occur within the supply chain. We had been talking about insider attacks for a long time, but generally when we talk about insider attacks, it really spoke to compromised credentials. Someone
Okay.
who either a threat actor was able to guess at a password, weak passwords, or
Mhm.
we've seen incidents where they bribed employees to get passwords. But generally, when we talk about insider attacks, that's what we talked about, was somehow they now got valid credentials and were operating within your environment.
Mhm.
And now we saw instances where the SolarWinds, the actual software vendor itself was compromised in order to get to an end user or to their end users. We saw that with Kaseya, getting into a managed service provider to be able to get to their clients with a ransomware attack. And
Mhm.
so it really did open up many, both on the security side, but now on the development side, can we trust our supply chain? There are so many third-party components that we bring into our development, both commercial and open source.
Mhm.
And can we trust that these are actually not only valid vendors, but they themselves have not brought something in that's already been compromised into our environment?
Mhm. Mhm. Yeah, I think it's definitely changed trust itself and the parameter and what is the parameter. And one of the ideas that the DevOps movement introduced was just shift left, and how the QA team and the ops team got to be brought in earlier in the pipeline. But then recently, there's been talk about shift left security, and security being brought in earlier in the pipeline. What are some examples of this, and what does it mean? What does shift left security mean in practice? What are your thoughts on that?
Yeah, so what we've seen is, just like you said, that as we've shifted left, we've brought testing further left and involved, instead of having a siloed quality assurance group and waiting a little bit more waterfall, we've
Mhm.
now, obviously, we have more continuous testing. How do we just continually develop, test as we're developing with faster iterations? Similar with security, what we've seen is we want developers to be thinking about security much earlier in the process, even in the architectural phase, to
Mhm.
be considering security, so that we're building applications that are secure as best as we can. Because,
Mhm.
and as we'll get to, things still happen, but we
Mhm.
want to, as best as we can, ensure that we're not introducing vulnerabilities into our code, into our cloud configurations in the platform itself, where a threat actor has an opportunity to take advantage. And we've seen, if there is a foothold to be had, a threat actor will find it, and they'll be able to then use that to find ways to penetrate deeper into the environment. And so we have seen different organizations have different names, right? Whether they want to call it DevSecOps, sometimes it's just a responsibility of an SRE or a platform engineer. We're seeing security definitely now much more involved in the development process, where even in integration, in testing environments, in staging environments, looking for vulnerabilities both at the code and at the configuration level, through static code analysis, through products where I'm tracing application, performing application tracing, and just the cloud configuration itself. And as we get into containerized environments and orchestration with Kubernetes, these are not, it's not like we've had 10, 15 years of Kubernetes, environments. These are very new, capabilities and technologies, and the configurations are fairly complex and become increasingly complex with, larger projects, larger development teams. And so the opportunity for misconfiguration is extremely high. The opportunity to leave a certain variable out that opens you up to potential exploit is very, very high. And so having an ability to continually look for whether it's vulnerabilities or misconfigurations becomes paramount for development teams in the site reliability engineering teams.
Yeah, and you were talking about you mentioned some of the different kinds of security priorities, talking about containers, you're talking about tracing and, just monitoring the networking activity. So the security itself, there's different components to it, and the conversation is definitely becoming deeper, which is a great thing, but there's different aspects to it, and so Spyderbat, I can see, focuses on runtime security. How does this tie into other aspects of security, like container security, networking security, and all of these other aspects of security?
Sure. Yeah, we kind of see there's kind of three legs of the stool. There's kind of securing the build, there's securing the platform, the cloud configuration, and then they're securing the workload. And so we focus on that third, just what happens at the workload at runtime. And the reason why we look at runtime, Gardner uses these terms of intended state and observed state. And I really like that, because the intended state is, I've built an application to do X and it should behave in this way. As we all know, what we want it to do and what actually happens are not always the same. And there's many reasons why, whether it's because I brought in some third-party component, which is supposed to only do X, but it also does this outbound network connection to an API service I didn't realize it did, or things along those lines. There's or it's just my application itself, new features, new capabilities introduce new workload behaviors that were not anticipated. And so understanding what actually happens at runtime, not just the preparation, not just looking for vulnerabilities, but understanding now when it's running, what actual activities do we see, what actual behaviors do we see, becomes just as important to the preparation side, so that when something weird does happen, something outside of the expectation occurs, that happens, because that's not always the case. There was a Red Hat survey of Kubernetes users, and more than half of the respondents indicated that they worry about runtime the most. And it's because they have the least visibility to what's actually happening. So one is just detecting that something outside of your expectations occurred. And then it's understanding, well, what caused that? Is it from the code? Is it from the configuration? Is it from an external source, a threat actor? So being able to make that determination as fast as possible to now remedy that becomes very important.
Yeah, that's interesting. And could you mention the Gartner term again? I just wanted to call that out because it's important.
Yeah, what Gardner calls they have two states. There's the intended state and the observed state. And so what we see is what actually happens at runtime is that observed state of what actually happens when you execute that code. And executing that code doesn't mean production. This could be an integration environment. It could be a staging environment. There are many environments where we execute our code before we get to production. And in any of those environments, we can introduce vulnerability. We can introduce aberrant behavior that can impact the platform or impact the application's performance.
Yeah, this actually ties into the whole idea of being declarative, which is very central to cloud native and Kubernetes, that you declare every part of the stack, and you deploy what you declare, and you expect that what's running is what you declared. But then organizations are at different points in their cloud native journey, and not all of them declare everything. A lot of it is done manually, ad hoc. So that being the case, how do you see that is a challenge for security? But how would something like a Spyderbat, how does a product like Spyderbat handle customers that are at different stages of their journey when it comes to being declarative?
Yeah. Well, the first is really, just understanding just current state, what actually happens in that observed state, in that runtime environment, across, whether we're talking about pre-production to production, what are our actual activities? What processes are run in our workloads? What network connections get created? What services talk to what services? Getting just that steady state of activity in our Kubernetes environment. So now we can understand, do we want that behavior? When I built out this application, I expected it to do X and Y. Am I seeing something beyond that I wasn't expecting? And is that okay? There's an API call going out to a different service. I didn't realize that took place. That might be completely fine. At least now it's a known, as opposed to just something that's happening under the seams, under the covers. To your point, now I can have that. Once I understand my steady state, now I can be more declarative. I can put myself in a position where, all right, we're building a new feature. For this feature, we're going to need our cloud configuration to change in this way. We're going to now have these API calls. We have a new service, and within that service, there are certain files that get created and read. There are certain network connections that get created. I can now understand what I want my application to do, and then observe, is that what actually happens, or are there other behaviors that came along for the ride?
All right, interesting. And when it comes to like runtime, there's of course the angle of there's of course the aspect of what you defined and deployed, which is kind of like an inside out approach to security, and then there's the outside in, which is the different threat actors, the different CVEs that are surfacing each day. There's both these directions that you need to take, when it comes to security. How does a Spyderbat approach this? Where does it put more focus, or does it focus on both? In what way, if you could shed some light on that?
Yeah, absolutely. It does focus on both. It's funny, I use the exact same analogy. There's sort of the outside in and the inside out, because the outside in it's exactly that. They're threat actors. They're looking for any vulnerability, and it's sort of the old analogy where we as protectors, we have to know about every single hole and try to plug them up. They just have to find one hole, and they can get in. And so unfortunately, it does. The advantage comes to them, where as long as they can find any vulnerability that was missed in some way, they'll be able to find a potential foothold in. And there's lots. The easy answer is, well, just patch, right? Why don't you just patch everything you need to patch? And in a real world, we know it just doesn't happen that way. There are reasons why we can't always patch an application. If I patch this part of the application, this library isn't compatible with the new version, et cetera, right? So the dependencies really become an issue. Or it could be if I patch, I now need to redo this part of the capability, or where you don't get a feature out in the time that we needed to get it out in. So it could just be a timing issue. And so there's lots of reasons why we take risk assessments. We say we're not going to patch. We think it's low risk. We're going to just focus on these higher risk vulnerabilities, and there's still a risk there, but it's within an acceptable risk. Well, acceptable risk means there's still risk, and so where Spyderbat, where we fall in, is understanding exactly what's happening at the workload, understanding what your intended workload behaviors should be, and then recognizing either whether they're just new workload behaviors or there are indicators of compromise in actual potential attack. What separates Spyderbat from others is that we don't tell you about every single potential indicator of compromise. Okay. Spyderbat looks at the world through this lens of causality. We know what's caused what. This process started this process. This process received a network connection. This process created a network connection. And proactively, we're constantly building out this map of what's caused what. Within a container, across containers, service to service, we have this constant understanding of causality, of what's causing what. And as a result, it allows us to do a couple things. One is, when we see a new workload behavior, we know what caused it. We know what actually instigated this new behavior. So that could be indication of an inside-out attack, right? A supply chain attack, something you brought in on the inside, a compromised build server, a compromised supply chain, third-party component, et cetera. It also gives us the ability to see individual, what would otherwise be atomic or disparate detections. We see the relationship of these together. And what's interesting, when you look at real attacks, a web exploit, they come in through a compromise on a web server or web page, do a code insertion, get to the shell. These things are noisy. But when you deal with logs, when you deal with event-based detection mechanisms, you now have to recognize, generally manually, as the operator, this activity is somehow related to this activity. Well, we connect those dots by understanding the cause. And so we can score the entire trace of activities. So regardless of the order of the flags, time, a week between flag 1 and flag 2, we just recognize there are multiple flags of potential compromise in the same trace. And that's what we bring to the operator's attention.
Sounds really interesting. The terms AI and machine learning get thrown around a lot, and every other product these days says we use AI. So, is AI and stuff being used at Spyderbat, and in what way? I mean, is it at all AI, or is it something else? It's not really, you don't really call it that.
Yeah, it's really a great question. It's funny because we have at least two data scientists on our team. We're not using any machine learning in the product yet. There's certainly a lot of opportunity for it in our technology, but we intentionally are not using AI or machine learning, because what we build is this factual map, and we didn't want there to be any concerns of, there's an inference model that can somehow get it wrong, and now we have confidence scores. We're 60% sure this is what's happening. So what we build is just a factual recording. There's no guesswork. We're not guessing this process is somehow related to this process. We know we're collecting the system telemetry to understand the actual system calls between the kernel and the application to know that this is actually what caused what. And all we're doing is capturing that information and now building out that map, so that we have it. We can now perform analysis on that map, on this contextualized map of what's happening as it's happening. And so that's, maybe kind of a difference with Spyderbat versus other technologies that I've worked with is, Mark and Brian started with the picture in mind. They wanted to have this picture of what happened, and they went backwards from the picture. All right, what are the analytics we need to build this picture? What's the data we need to feed into our analytics? What I see a lot in the market is, let's collect a whole bunch of data, and then let's run analytics on top of that data. Let's see what we get. And what you get is you get a lot of noise because,
Mhm.
and I don't want to say garbage in, garbage out, because that's not fair. There's a lot of really intelligent analysis that's being performed. It's just that with a lot of data, you're going to get lots of observations. And so what we did is just a very kind of an inverse approach of, we want to be able to root cause anything that's happening in environments. We need to know the cause of everything. So how do we build that picture?
Mhm. Wow, really cool. I like that you just didn't tack on AI or ML as just for the namesake of it. But the next question I have though is, when you're saying it's factual and it's based on actual data, and you can actually say that this is a concern for sure. I think the component of time becomes important. How soon can you say this? And is it really lagging? That would be a problem. Is it real time? How real time? If you could just shed some light on that. How do you handle the time
Yeah.
between it happens and it's reported, and the customer can actually respond to it?
Yeah, really good question. So there, in really what Spyderbat does, there's three ways that we can recognize some sort of intrusion. The first is admittedly a bit of a signature-based approach, but the signature is using those causal relationships. So example, log4j, which you brought up earlier, we now know, now we know what a log4j, an attack to that exploit looks like. We're going to see a network connection come into a Java thread. We're immediately going to see an LDAP outbound request followed by a Java class that gets downloaded. We're going to then see some sort of activity on the shell. So there's this causal relationship between those processes and those network connections where we can recognize that. We know that's an exploit attempt to log4j. We know that it's landed. It actually got to a shell rather than just it bounced off the firewall or it bounced off a patched version of log4j. And now we can take action on that. So we call that a shield for known vulnerabilities, where we can now just immediately see that. We don't have to wait to see, is this going to become an attack? Now, the other way we can recognize an intrusion is just by recognizing new workload behaviors. So we can fingerprint a workload. This microservice, it runs these processes, it creates these network, these API calls, it's expecting this one network connection to come in. And again, we know that causal relationship. We know that this process is supposed to start this process, and it's supposed to run as this effective with the effective user rights of this user. So we can build that into a fingerprint and now just tell you about, or even take action on new workload behaviors. So again, other than having to build that fingerprint based off of previously observed activity, once that fingerprint is created, there's no delay in our ability to take action. And then the third way, which is that scoring that causal trace, that's where we do want to see multiple flags. So there could be some time that we're seeing multiple flags. Now, when we see real attacks, we're going to see multiple flags. But what's interesting is the time delay. I download a compromised, library without realizing it. And a lot of the attacks, SolarWinds, right, they waited this random wait period between 10 to 14 days before they detonated their malware. Why 10 to 14 days? Well, they know most QA cycles or most iterations, they're 2 weeks. And so if they can wait outside of an iteration, now they're probably in another iteration, the malware deploys, no one's looking at it anymore to see if this library does anything weird. And they can now kind of perform their devious activities, right? So if this does wait 2 weeks and now it detonates and we start to see concerning activities, not only do we recognize those concerning activities within a very short period of time, we also still know 2 weeks ago that this library was the source when it was installed and executed.
All right, really cool. We're winding down. We've got the last few questions, but yeah, I just want to ask about how Spyderbat collects its telemetry data. Is there an agent? You mentioned events, logs, and tracing. Are these part of it? How does Spyderbat get its data? What data?
Yeah, we use a So what we're using is eBPF, which is available. So we do have an agent. That agent's essentially writing eBPF filters to collect, process, and network data. So eBPF, if you're not familiar with it, or those who are listening who may not be familiar, within the Linux kernel itself, eBPF was an extension from Berkeley packet filters a long time ago. That's where like TCP dump came from. You could write, and it's interesting, it's literally this virtual sandbox within the Linux kernel. And so it acts extremely efficiently to basically be able to ask the kernel, if I see a system call that looks like X, it has these particular features to it, tell me about it. And so we leverage eBPF to deliver from the kernel space to user space information about new processes, new network connections. So we're not trying to collect all things that eBPF, you could actually trace every system call in Linux. So we have a very focused collection of data from eBPF, which keeps it extremely efficient, extremely lightweight. And we build, essentially what's caused what. We take that and we perform the processing on our side to basically build out that map and perform analysis on that map as that data is coming in. So it's a purpose stream processing engine. Brian likes to joke, this is like his sixth generation stream processing engine that he's created in his life. So we have a lot of experience in doing this really at real time. If you recall Tipping Point, as a network-based IPS, that had to look for malicious payloads at wire speed within packets to be able to block a flow. Well, obviously, we're not doing that with Spyderbat, but it's the same mentality of how do we do this type of processing extremely quickly to make decisions, to make determinations.
All right, nice. Yeah, and I want to ask about with Spyderbat, does it support hybrid workloads as well, or is it purely cloud focused?
Yeah, really good question. The underlying technology works on Linux systems. It doesn't have to be containerized even. It could be bare metal Linux. What the feature set we have built is very container aware. So it allows you to see what's happening in a namespace, what's happening in a pod from service to service. So we've certainly built a lot of capabilities for containerized environments, especially on the kind of the runtime visibility. But yeah, hybrid users who, we have customers where they still have large, just EC2 nodes, non-containerized, just running Linux on EC2 nodes. We have one customer that they sort of inherited this large bare metal Linux environment. And what's interesting, one of their initial use cases was that there was all this just things running on these Linux systems that they had inherited, and the security team was trying to make, just trying to understand it. And they were literally going line by line through scripts to try to figure out what these scripts do. With Spyderbat, they just run the script, and then they can see the outcome captured by Spyderbat. Oh, this is what the script does. So yeah, so we very much can operate in hybrid environments.
All right, cool. How does pricing work with Spyderbat?
So we price per node. So, and what's interesting is by running, on the Linux node itself, it doesn't matter how many containers you're running. We're not a sidecar. We're not running as a container. So it becomes really easy from a deployment perspective. We could just be added to like a Helms chart to deploy us out in a Kubernetes environment, or even just like a Terraform or Ansible script if you're taking us just to EC2 nodes, for example. And then from a management perspective, because you're not running us within each container as a sidecar within your cluster. We're just there on the node itself. So the pricing is just based on the node. And so those nodes can come and go throughout the subscription period.
Yeah, sounds fairly predictable, the pricing that way. I noticed on your website that you have a game. It's called Defend the Flag. Sounds fun. Could you talk a bit about it?
Yeah, I'm glad you asked. It really is fun. It actually came from, when we were testing Spyderbat, one of us would go and essentially hack a system with Spyderbat running on it. And then we would have the what we call a spider trace, right? That trace of activities that was captured. and we send it over to someone else and say, hey, can you figure out what I did? And it's kind of fun to like, oh, okay, you came in through an SSH port, and then you got to a bash shell, and you're following along the attack, as if you're sitting on the shoulder of that attacker. And so what we did is we gamified our product, where we have previously captured attacks or other types of scenarios, and we just give you like 5 questions, like what IP address is the attacker? How did they escalate their privileges to Bob? Things that if you're an operator, you'd be trying to figure out the answer to these questions anyway. And so they're real exploits. They're the real Linux systems or containerized environments where we've left some sort of vulnerability, and then we've attacked it and exploited those vulnerabilities. So this is how it actually looks on the system. So we even have one of our customers. It was funny. All of a sudden we saw like 15, 20 signups for a Defend the Flag from this one customer. So we asked them, what is going on? They said, oh, once a week we're going through one of your challenges. And so the senior analysts, they're teaching the juniors, kind of what this attack was and how it operated. And so they were just using it as a training exercise, just to understand Linux or Linux attacks. Not, it doesn't even have to be about Spyderbat.
Wow, full points for making security fun.
Yeah, thank you.
So with that, we come to the end of our conversation around Spyderbat. I think it was quite enlightening, and thanks a lot for sharing all of those ideas. Really appreciate that. Before you go, Seth, just have a few questions to get to know you a little better. So here goes. What would be your alternate career if not for your job in tech?
Yeah, it's funny. It's actually a more challenging question than you might realize. There's really the passions I have outside of technology, and I've been in computer science technology for a long, long time. But funny enough, I was an English and film studies student as an undergrad. It had nothing to do with computers, and so writing and film are definitely areas that I just love a lot. In fact, what got me into film was screenwriting. I was actually writing screenplays in college for fun, and I really enjoy the film industry. So, interestingly enough, it still actually is connected to my day job today, because it's all part of this creation process. And I think that's what I really like at the end of the day, is just the creativity, the creation process, and creating things. And so, yeah, my alternate career, I think it would be a writer. Be probably writing funny novels you would find in the supermarket checkout.
Wow, really cool. So you probably have a very critical eye when you watch a Netflix show or a movie.
Yeah. There's, I won't ruin it for people, but a lot of films, as diverse as films are, they follow a particular pattern in terms of when's the first turning point, the second turning point, what the third turning point is. And once you know that pattern, you see it in every movie you watch.
Story. Yeah. Wow. Sounds really interesting. One work tool that you can't live without.
Yeah. Probably I would say, well, I mean, so Spyderbat's a virtual company. And as a virtual company, we basically live on Zoom and Slack. And so those are the 2 tools right now, because it's my tether line to the rest of the company. When Mark and Brian started Spyderbat, this was pre-pandemic, decided we were going to be a virtual company, because in this day and age, tying yourself to one location when there's talent all over the world, they recognize that it just didn't make sense, and we could be better as an organization by drawing talent from wherever those individuals may be. So Slack and Zoom, I'll put a plug in for them.
Yeah, the tools for today, Slack and Zoom. What's one software tool or product that you think is very elegantly built? Yeah,
I struggle. You send these questions. There's lots of products that I think are elegantly built. I was trying to who do I want to give props to in our time together. I didn't come up with a good answer, as you can tell. I was thinking about a few different ones. but I don't have a good recommendation for people.
Yeah, sure. Yeah, just mention
I'm
a
not a
few that
great
cross your
UI
mind.
UX person. Yeah.
All right, all right. Okay, cool. What's the last thing you Googled?
So the last thing I Googled, you're going to laugh, but it was, there's a website, their unofficial website that hosts all of the Kubernetes, during the conference next week, the KubeCon, Cloud Native Con, they list all the parties. And so I Googled for that website because I was who's sponsoring what parties are there going to be. So maybe there's a tool people might be interested in. They don't do it just for KubeCon. It's a funny website, but they list for all the conferences. They find all the different parties that people are sponsoring, happy hours, etc. So if you like going to these conferences and socializing or finding ways to connect with others, it's a pretty good website for that.
Do you remember the name at all?
Hold on. It's called conferenceparties.com.
Okay. Yeah, it's pretty simple. Check it out. Do you have a favorite tech blog or website or writer or book, or anything that comes to your mind when you think of?
Well, so on the marketing side, I'm a big fan of Seth Godin. Seth Godin is the first marketing book I ever read was called Purple Cow, which it kind of got me. And in fact, he's written many books, and he's he shifted a bit of his focus from marketing to community building. He has a great book called Tribes, Tribes specifically about community building. And another book of his I love, and I always recommend to people, regardless of what field they're in, it's called Linchpin. And the book Linchpin really describes how do you become essential to your organization. So again, regardless of your role, how do you become someone who the organization really finds you're a necessity? You're someone who just helps that organization in unquantifiable ways. And so I always love recommending that book. He does have a blog as well. He's on Twitter, although he doesn't post a whole lot, or he doesn't tweet a whole lot on Twitter, but he does write quite a number of articles on his personal blogs.
Yeah, I've been subscribed to his blog for more than a decade. I mean, I'm amazed at how consistent he is. Every day he writes a few lines, and it's amazing, quite insightful.
Absolutely, I agree.
Yeah. So where do our viewers find you online, Seth?
Yeah, I'm on Twitter and LinkedIn are probably the two best ways to find me. And yeah, definitely encourage any discussion, conversation, questions. I enjoy that type of interaction.
All right.
So on Twitter, I am so-called Seth. SOCALLED Seth, so-called Seth, on Twitter, if you want to find me.
All right, cool. Thanks so much, Seth. It was a pleasure having you. Really enjoyed our conversation. And for our viewers watching, I want to encourage you to head over to Spyderbat. It's spelled with a Y, right? Spider.
That's right. Yeah, SPYDERBAT.com, Spyderbat.com.
Yeah, so head over there and definitely check out this game that they have, Defend the Flag. Looks really fun. So with that, Seth and I are going to sign off, but definitely head over to amazic.com as well. And you can continue learning much more on these kind of topics as we keep talking about them. Thanks a lot for joining us, everyone. Thank you, Seth.
Thank you very much. Really appreciate it.